Hello everyone. Welcome to this workshop on Publish Your Own Routing Services. I am Dilesh Mandloy and helping me is my colleague Max Zeng. We both work as product engineers on the network analyst development team out of Esri's Redlands office. Before we get started, all the slides and the demonstrations that we will show today are available for you to download at this URL. In today's workshop, we are first going to briefly cover some routing concepts so that if anyone is not familiar with routing, they can get an idea of what we are talking about. Then we will look at what is the publishing workflow that you can follow to publish your own routing services to ArcGIS Enterprise. To understand this workflow, we will see how you can publish routing services as geoprocessing services or as map services with network analysis capability. Finally, we will look at how you can use these routing services. Now let's understand some of the key concepts related to routing in ArcGIS. Routing in ArcGIS is done with the Network Analyst extension. This extension is used to perform analysis on transportation networks that model how travel occurs on streets. A transportation network is different than a facility network, such as an electricity distribution network. The ArcGIS Network Analyst extension does not work with facility networks. In this workshop, we are focusing on transportation networks. If you need to learn more about the facility networks, you can check out other workshops. Network Analyst extension supports 6 different analyses that solve some problem using a transportation network. You can also think of them as 6 different solvers, or as we will see in this presentation, you can publish each of these 6 solvers as services. So you have 6 solvers which you can publish as 6 different types of routing services. In this slide, I am showing you a categorization of how to think about these 6 different solvers. The first category is point-to-point routing, where we have the route, closest facility, and origin destination cost matrix solver. The route solver allows you to find the best route between 2 or more stops with the option to optimize the sequence in which you visit the stops. You can specify some additional constraints such as the stops that can have time windows or account for live traffic while finding routes. The closest facility solver allows you to find one or more closest facilities from a given incident. For example, you might have an accident and want to dispatch the 3 closest police cars to that accident that can reach the location site within 5 minutes. The origin destination cost matrix solver allows you to find the travel times and travel distances between all of your origins and all of your destinations. You can optionally specify the number of destinations to find from each origin or specify a distance or a time-based cutoff. The next category of solvers is optimization, where we have vehicle routing problem and location allocation solvers. The vehicle routing problem solver allows you to find routes for a fleet of vehicles. Let's say you are a delivery company that wants to deliver 25 different orders and you have 3 drivers to make these deliveries. This solver allows you to figure out which order goes to which route and in what sequence the orders should be visited. You can also specify other constraints such as time windows that should be honored when visiting the orders, or if your drivers should have breaks in their working schedule, or if you need to ensure that drivers do not work for long hours. All such constraints can be specified as inputs to this solver to find the optimal routes. The location allocation solver allows you to find the best facilities that can fulfill the demand for those services and accomplish a goal. For example, you may have 2 existing coffee shops and have budget to open 2 new shops. You can use this solver to figure out where do you open those 2 new shops while still keeping your existing shops to maximize the number of customers that can visit your shops. The last category of solvers is coverage, where we have service area solver. Now, the service area solver allows you to determine the areas you can travel to from one or more locations. This solver can be used to figure out what are the trade areas for your stores and how many customers are within 30 minutes of your stores, for example. In the previous slide, We looked at the different types of solvers or analysis that you can access when working with network analyst. Now, these analyses are done on a network dataset that models your transportation network. This is where you define how streets are connected to each other and also have the rules that define how travel should occur on the network. For example, which streets are one-way streets and where are the underpasses and overpasses. All of this information is stored in a data model, which in ArcGIS is called a network dataset. The routing or the network is always done on a network dataset, which is stored within a geo database. Do keep in mind that without a network dataset, you cannot perform any of these analyses. Even when you are working with routing services, these services need to use a network dataset. In the previous slide, we looked at the different types of solvers or analysis that you have access to when working with a network dataset. So where do you get a network dataset? Esri offers a product called StreetMap Premium that includes a ready-to-use network dataset based on high-quality street data. The StreetMap Premium product also has an option called Custom Roads that allows you to add your own streets to the existing streets. If your organization maintains street centerline data, you can use it to build a network dataset. In case you wish to pursue this option, ArcGIS Pro provides guided workflows on how to create network dataset using street centerline data. I have included the link where you can find these details. You can also build a network dataset from street data provided by the government, such as the Tiger data in the United States. You can also use free data, such as from the OpenStreetMap project, to build a network dataset. Finally, if you don't have any street data to build a network dataset, ArcGIS Online provides routing services that you can use. Those services use the same data as StreetMap Premium, but you don't have to own the data. You just pay service credits and let the servers managed by Esri do the work for you. Now let's understand some of the key concepts related to ArcGIS Enterprise. This workshop is not going to cover all the details about ArcGIS Enterprise. You can learn that from other presentations. My intention here is to explain how ArcGIS Enterprise allows you to create and manage routing services. In this slide, we have an illustration that I like to explain what ArcGIS Enterprise is. I'll explain going from bottom to the top. As we previously learned, routing services need a network dataset. You store the geo database containing your network dataset on one or more servers. These servers also host your routing services. The servers federate to an enterprise portal from where different applications such as ArcGIS Pro or MapViewer or your own apps discover these routing services and use them. This is how you enable WebGIS in your infrastructure. The infrastructure can be running on your premises or can be in a cloud environment that you manage. If you have used ArcGIS Server before, you might be wondering what is ArcGIS Enterprise. ArcGIS for Server had its name changed to ArcGIS Enterprise in a previous release, so the two are pretty much the same thing. ArcGIS Enterprise allows you to implement a WebGIS. A WebGIS provides GIS capabilities as one or more GIS services. A GIS service is a GIS resource running on a server machine. Contrast this with a GIS application that you may have used, such as ArcMap or ArcGIS Pro, that runs on your local computer. A GIS service, on the other hand, is an application that runs on a server machine. The benefit of using a GIS service as compared to an application running on your local computer is that many different applications can simultaneously use the capabilities provided by the GIS service. To create GIS services, you share the GIS resources, such as a network analyst solver, to the web using one of the service types that ArcGIS Enterprise supports. For routing services, we will focus on different service types that ArcGIS Enterprise provides, such as the geoprocessing and network analysis. Let's see how you can publish routing services using geoprocessing and network analysis service types. Now, before we learn about service types, I often get this question asked by users: should I use ArcGIS Enterprise or ArcGIS Online? Both have routing services, so your decision should really be based on few criteria. If you don't have your own street data or have a StreetMap premium product, that you have access to, then you need to use ArcGIS Online Routing Service. Now, if you do have street data, do you have ArcGIS Enterprise and the Network Analyst extension for ArcGIS Enterprise? If yes, then you can publish your own routing services. Otherwise, you need to use ArcGIS Online Routing Services. When you're publishing any GIS service, such as the routing services, to your ArcGIS Enterprise, you always follow this three-step workflow. First, you author a GIS resource. Then you publish that GIS resource to get a service. Next, you share that service to your enterprise portal and use the service from one or more applications. We will see how we can implement these three steps in the subsequent slides. ArcGIS Enterprise allows you to publish GIS resources as many different service types, such as a map service or a geocoding service. Now, you can publish routing services as either a geoprocessing service or as a map service with network analysis capability. If you read the API reference for routing services or use routing services from the services directory or manage them using applications such as ArcGIS Server Manager, you will often see geoprocessing services being referred to as GP server and the map service with network analysis capability being referred to as NA server. I want to call out these terms GP server and NA server so that you can relate to them when working with routing services. Now let's look at how you can publish a routing service using a geoprocessing service type. In previous slides, we looked at a three-step workflow to create GIS services: author, publish, and use. In the illustration on this slide, you can see in order to publish a geoprocessing service, you need to have a geoprocessing script tool that performs your desired analysis by executing Python code based on ArcPy and ArcPy.nax modules. Once you have your GIS resource, in this case, a geoprocessing script tool, you run it in ArcGIS Pro and publish the tool result as a web tool. Publishing the web tool gives you a geoprocessing service that you can then share with others in your enterprise and start using the services from out-of-the-box applications such as ArcGIS Pro or MapViewer, or programmatically from your own applications created using ArcGIS APIs and SDKs. So to recap the three steps, you author a geoprocessing script tool, publish the tool as a service, and then use it from applications. You can also create routing services from map services. In this case, the GIS resource you need to author is an ArcGIS Pro map containing one or more network analysis layer that references the network dataset. In the illustration on this slide, I have an ArcGIS Pro map with three different network analysis layers representing a network analyst solver. The next step I need to do is take this map and publish it as a web layer. When I am in the process of publishing this web layer, I need to enable the network analysis capability. This is important. Otherwise, you only get a map service and not a map service that has network analysis capabilities. Now, once you have this map service, you can use the routing capabilities from your apps. Unlike the routing service created using a geoprocessing service, a routing service created from a map service cannot be used from any of the out-of-the-box applications such as ArcGIS Pro. Instead, you use such routing services programmatically from the APIs and the SDKs. Now, in the previous slides, I described two different service types that can be used to create routing services and how you can publish them from GIS resources. To simplify this process, ArcGIS Enterprise includes a utility called Publish Routing Services utility that takes a network dataset and performs the task of publishing all these routing services. The Publish Routing Services utility is still performing the same steps that I previously described, but it does that in an automated way. The Publish Routing Services utility is included with ArcGIS Enterprise versions 10.6 or later. It takes a network dataset, some other information to connect to your ArcGIS server, and then it will create all the routing services. If your ArcGIS server is federated with an enterprise portal, the tool also registers all the routing services as utility services in your portal. Now, in order to run the tool, you need to have an ArcGIS Network Analyst extension license for your ArcGIS server. You, however, do not need to have a Network Analyst extension license for ArcGIS Pro. Now, this figure is showing the different types of services that are created by Publish Routing Services utility. The tool creates a geoprocessing service called Network Analysis that includes the 6 different tools to work with the network analyst solvers. This service supports asynchronous execution mode and is best suited for executing long-running requests. The tool also publishes a map service with network analysis capability that supports synchronous execution mode and is best suited for short-running requests. The tool creates an auxiliary service called Network Analysis Utilities that provides information about the network dataset used by the routing services, such as the list of the supported travel modes. Now, along with publishing services, if your ArcGIS server is federated with an ArcGIS Enterprise portal, then the Publish Routing Services utility registers these routing services as utility services in your portal. This enables various applications such as ArcGIS Pro to discover these routing services and use them. Now, when you upgrade ArcGIS Enterprise from an older version, the upgrade process will create the routing services if they were present in the old deployment. However, this may cause the routing services to not work correctly or miss the new functionality available in the new version of ArcGIS Enterprise. So, as a best practice, you should delete the existing routing services and recreate them using this utility. Another use case is when you are refreshing the StreetMap premium data used by the routing services. Even in this scenario, you should delete any existing routing services and then recreate them so that the services know how to work with any changes made to the schema of the street data. Now, once you have published the routing services, you can use them from many different applications like the map viewer, which is available with your enterprise portal. Now within MapViewer, you can use these routing services from the directions button or from many of the analysis tools such as those within the use proximity category. You can also use the routing services from ArcGIS desktop applications. If you are using ArcMap, you can make a GIS server connection and access these services as geoprocessing tools. If you are using ArcGIS Pro, you can go to the network analysis gallery, set your network data source to your enterprise portal, and perform network analysis. With that, I'm going to hand it over to my colleague Max, who will show you a demonstration on how to use the Publish Routing Services utility.
Thank you, Dilesh. As Dilesh mentioned, the best way to publish a default routing service is by using this Publish Routing Services utility. It takes care of authoring, publishing, and configuring for you, so you don't need to do it on your own. And it also embeds some performance tricks, so you are guaranteed to have the best routing services published using this utility tool. And as Dilesh showed you in his slides, we have very good documentation on how to use this utility tool to publish routing services, like how to prepare your data, what parameters you need to pass to the service and how to pass the parameters, and some of the examples. We started to ship this publish routing services utilities with ArcGIS Enterprise in version 10.6, so you'll be able to find the documentation that matches the version of your server. So this utility was originally a standalone Python script, and you just use the Python on ArcGIS server to call it. In version 10.8 or later, we improved it so it is now a batch file, making it even easier for you to use this utility. So I want to show you how you can run this utility script. So here on my server machine, I installed 10.8.1 ArcGIS Enterprise. So first I want to show you how to find this Publish Routing Services utility. We can cd to the server install folder, which is under Program Files, ArcGIS Server, and then go to Tools. Now our Publish Routing Services is within Tools, and we can take a look at it. We have this Publish Routing Services.batch file. And let's take a look at what are the parameters that it's expecting. So we can do a -h. It's going to print out the help for this tool. So some of the parameters I want to highlight is the username and password, which is the primary set administrator for your server or for your portal if your server is federated with the portal. The server name needs a fully quantified domain name for the server machine, and the portal name is a fully quantified domain name for the portal machine if your server is federated with the portal. and this takes in the network dataset. And the service definition folder stores the service definition that is created by this tool while the utility is running. And there is also a log file which helps to debug if you run into any issue with this utility. So by default, it's going to create all the services in a folder called routing on the server. And if you want it to be a different folder on the server, you can pass this -f. So to use this publish routing services utility, you can pass each of the parameters one by one, and -n to pass the catalog path of the network dataset. Or you can just store all the params on a file, and you will be able to pass this file to the publish routing services batch file. So here I have a publish routing services underscore params.txt, and let's take a look. I specify my username password, the 2025 domain name for my server and for the portal, and then I'm publishing using the San Diego tutorial network dataset. So for the folder on the server, I set it to routing underscore SD. And once I have this param file, what I can do is I can copy the path of the param file, and I will be able to just call this batch file with an @ symbol and paste the path to the param file. And it will take each of the param in this param file and publish the routing services based on the params that defined in the param file. So this tool takes around 10 to 20 minutes to publish the services, depending on how fast your machine is. And after publishing the services, it creates all the services in your server and registers the utility services in the portal if your server is federated with the portal. So now let's take a look at what actually gets created on the server and registered in the portal. So on my server manager, I have this routing underscore SD that matches the folder name I passed in my param file. And this publish routing services utility helps to publish this 4 set of services. The network analysis geoprocessing service is our asynchronous geoprocessing service that used to solve larger problems. We have a task for each of the 6 solvers, so this is a set of 6 services. The network analysis map service is our synchronous network analysis service that is used to solve smaller problems. We also have the synchronous version of the geoprocessing service, which currently is only including the synchronous vehicle routing problem service. The network analysis utility service has some utilities that other tools and apps is using, for example, get travel mode or get tool info. On the portal, because when I publish these services, my server is federated with the portal, so it helps to register the utility services on the portal. If you sign into the portal with an administrator account and go to organization, go to settings, and go to utility services, we have this directions and routing section. And you can see each of the utility services is registered by my script tool. So why does this matter? Because this is how the other out-of-box applications like MapViewer or ArcGIS Pro discover the services from the portal. So let's take a look at the MapViewer first. On the MapViewer, we have this directions widget, which can help you to find a route between 2 points. And this is actually using the synchronized route service we registered on our portal. And we also have these analysis tools. Under Use Proximity, we have the Create Drive Time Area Analysis tool that helps you to create the drive time area around the facility, and this is actually using the asynchronous geoprocessing service, the service area service that we registered here. Find Nearest will find the closest facility to your incident, and it's using the asynchronous closest facility geoprocessing service. Plan Routes is used to route a fleet of vehicles, and it's using the asynchronous vehicle routing problem geoprocessing service. Connect origins to destinations is actually using the asynchronous route service because it is solving a route to connect origin to destinations. And under Find Locations, we have the Choose Best Facilities tool, which uses the location allocation asynchronous geoprocessing service. When we do network analysis in Pro, we can go to Analysis, Network Analysis dropdown. You will be able to specify your portal URL as a network data source. And when we create a layer using the portal URL and solve this layer, it actually just calls the services that we just published on our server. Pro knows how to discover the service area service on the portal because we registered the service area service on the portal. Now, if we just do a simple service area to find a 5, 10, 15 minutes of drive time around the facility in San Diego area, what we can do is we can just click run and it will solve this service area. And while it is running, we can take a look at our server and you are seeing that the instance in use changed from 0 to 1 while we are solving, and it tells you we are using the geoprocessing service to solve our service area. And this is the 5, 10, 15 minutes of driving time area around this facility. So one thing I want to mention here, because I published my service based on the San Diego network dataset, so I'm only able to perform my analysis in San Diego area. I wouldn't be able to perform my analysis in Los Angeles because I don't have my streets data for Los Angeles area. So to summarize, the published routing services utility tool is very useful and powerful. It helps to publish the services and register your utility services on the portal if the server is federated, and it is the recommended way to publish your routing services on your enterprise. Back to you, Dilesh.
In his demonstration, Max showed you the Publish Routing Services utility. If you need routing services to work with out-of-the-box applications, you need to publish the services using that tool. Sometimes though, Publish Routing Services utility may not be the tool that gives you the routing services that you want. In such cases, you need to publish your own geoprocessing service. For example, Publish Routing Service utility creates routing services that are meant to perform a particular task, such as finding the best route between two or more stops and generate driving directions. But what if you need to perform additional analysis along with routing, such as to calculate an elevation profile for the route? In this case, you need to author a geoprocessing tool and publish it as a service. Another scenario is when you want to combine multiple network analysis in a single service. For example, determine the accessible open houses and then find the best route to visit them. How do you publish your own geoprocessing services? As we have seen earlier, we can follow the three-step workflow. Author a geoprocessing script tool using ArcPy and ArcPy.NAX Python module. Publish the geoprocessing tool as a web tool, and then use the geoprocessing service from different applications. Let's look at how you can write a geoprocessing script tool that performs network analysis. The routing functionality in your script tool is done using the ArcPy.NAX module, which provides easy to use classes and methods for performing network analysis. This slide shows a summary of the workflow you will want to use for performing a network analysis, such as calculating an OD cost matrix. You first initialize an analysis object. Next, you set the properties for the analysis. Then you load the inputs for your analysis. You solve the analysis and finally work with the results. This graphic shows how to perform an origin destination cost matrix analysis using objects from ArcPy.NAX module. You initialize the origin destination cost matrix solver object. On the object instance, you set one or more analysis properties. Then using the load method, you set up the analysis inputs. Then you call the solve method to run the analysis, which gives you a result object. You can use the export method on the result object to work with the results. So I showed you in the previous slide the 5-step workflow, and this is how you actually implement that 5-step workflow using the objects from ArcPy.NAX Python module. Now, this code snippet shows how a geoprocessing script tool looks like. You will need to write something similar for your own geoprocessing services. In this example, we have a function called getDirections that generates travel directions based on a travel mode. So within this function, we first read the inputs passed to the tool. Then we initialize the route solver object and set the analysis settings. We load the inputs into the solver object. We solve the analysis, and then we export the directions into a feature class, which are then subsequently returned from our geoprocessing service to the client applications. Now, here are some tips and tricks when you're writing geoprocessing script tools that are meant to be published as geoprocessing services. Now, use a network dataset layer instead of referencing a network dataset from a catalog path. When you use a network dataset layer, the geoprocessing service will cache the connection to the network dataset when it starts up and use it for all subsequent requests. If you instead use a catalog path to the network dataset, each request needs to open a connection to the network dataset, which slows down your service. The geoprocessing framework in ArcGIS allows you to write geoprocessing models. Now, these models can be published as geoprocessing services. However, geoprocessing models that perform network analysis are slower to execute as compared to geoprocessing script tools written using ArcPy.NAX module. Another tip is to write outputs and intermediate data to memory-based workspaces instead of writing them to a file geo database to minimize the I/O operations made by your service. Finally, writing messages from a geoprocessing service is slow. So avoid writing too many informational messages from your script tool. That is, minimize the use of ArcPy.addMessage function. Now let's look at some tips and tricks when publishing geoprocessing services. Now, the end users of your routing services do not need to specify the network dataset used for routing. So hide that network dataset parameter from your service API by setting the input mode as constant for this parameter. When you are publishing the routing services, you have to tell ArcGIS server where is the network dataset that is used for the analysis. Now you should do this by registering the folder containing the network dataset in the ArcGIS server's data store and not let ArcGIS server copy this data for you. Why am I suggesting you this option that requires you to do more work? Now, when you register the folder in ArcGIS server's data store, you control the location where the data resides on your server as opposed to letting ArcGIS server control this location. One benefit of this approach is that when you need to perform a data update, you can swap out the old data with new data by simply stopping and restarting the service. When ArcGIS server manages the data, you will need to delete the service and republish it, which can be error prone and also increase the downtime for your service. It is a common practice to store the network dataset on a file share that is common to all the server machines in your ArcGIS server side. However, accessing network dataset from a file share is slow. The routing services need to access a lot of content from the network dataset. The faster the I/O is between your service and the network dataset, the better the performance will be of your routing service. So in a multi-machine ArcGIS server side, or even when you are using a single machine for your ArcGIS server side, you should copy the network dataset on every machine. And if possible, store the data on a locally attached SSD drive. So with those tips and tricks in mind, I will hand it over to Max again, who will show us how to create a geoprocessing script tool to solve a particular workflow, publish the script tool as a geoprocessing service, and then use the service from different applications.
Thank you, Dilesh. In this demo, I'm gonna show you an interesting workflow. For the context, I'm a real estate agent and my job is to provide my customer with a list of open houses and help them to figure out which open houses fit their criteria better, and also plan a route to visit all the selected open houses with them. I will first show you how to solve this in ArcGIS Pro. Then I will publish this workflow as a web tool so I can run this tool from anywhere. So one of the criteria my customer has is that the house needs to be close to the nearby grocery stores. For that, I gathered all the grocery stores in San Diego area, and I can do an accessibility analysis on the open houses. And I can calculate the distance from each open house to all the nearby grocery stores and calculate an accessibility index. Since I need to get a distance between open houses and all the nearby grocery stores, so this is an origin destination cost matrix analysis. Then for the open houses we select, we need to plan a route. Since each open house have their individual time window and we also need to spend around 30 minutes in each of the open house, we need to plan route carefully. For that, we can do a traveling salesman analysis to find the best route with the time window. We will use route analysis for that. So as you can see, this workflow requires several network analysis tools, and we don't have an out-of-box solution for that. That's when you need to create your own tool to solve this problem. And if you want to later share this workflow with other coworker or want to use it on the browser, then you need to take this workflow and publish it as a service. I will show you how to do this. So here is a script tool I built using Python, and we can open this tool and see the parameters. It first asks me to specify where I live, since my route would start and stop at my home address. I can click this pencil to add my home onto the map. Then it takes in a feature class that specifies all the open houses on the market. I will just pick the open house layer we have. And for the open houses to visit, we are interested in visiting 3 open houses for the day. And for the network dataset, I'm just going to use the San Diego network dataset that I have in my map. So I'm picking the San Diego network dataset. For the point of interest layer, I'm going to specify the grocery stores I have in my map. For the travel mode to calculate accessibility, I'm interested in doing a walkability analysis between my open house to the nearby grocery stores, so I will choose the walking distance. Since I will walk to the grocery stores, so I probably don't want to walk more than 1 mile, so the cutoff, we set it to 1 mile. And for the travel mode to calculate the route to visit all the open houses, because we are driving a car to visit all the open houses, that's using the driving time. And we can run this tool. And while we are running this tool, let's take a look at how we create this tool. So the first thing that we can take a look is the properties. And we can take a look at the parameters of the tool. You can see our open house is a featured set data type. This data type gives us the ability to interactively add inputs, like when we just click our home address on the map. So one important thing to mention here is that if you want to control what type of inputs you can specify for this parameter, then you need to specify a default for this parameter, which points to a layer. And the layer stores what type of input data it supports, what are the fields it requires, and what is the default symbology for this layer. And the next important thing is the network dataset. Here we specify it as the network dataset layer type. This is a performance trick we recommend to adopt, and Delight has explained why you want to do this. And then for the travel mode parameter, you can make them dependent on the network dataset parameter. The benefit of doing this is that our travel modes will then come from the network dataset, so only travel modes that are present on the network dataset will show up in the dropdown for this parameter. Then for the output, if you want to control the symbology, pop-up, and label of the output in Pro, you can specify a layer file which can store all the information. That's why after you run the tool, it can have those pretty symbology and label and pop-up. And if you want to document this tool, then you can go to the Edit Metadata, and we provide helpful information for each of the parameters. And this information will appear to you when you click the help for each of the parameter. And this metadata is also required if you will publish your tool as a service. Now we see our result. Let's take a look at our result in Pro. Here we have lines connecting our open houses with nearby grocery stores that are within 1 mile. Then we have a route that visits all the open houses that are selected. So the open houses that are not selected are shown in gray. When we click the open house, we will be able to see the start time of the open house, the end time of the open house, and when will we arrive and when will we depart from the open house. We spent 30 minutes at the open house. And it also shows us the accessibility score we calculated based on the distance between each of the open house and the nearby grocery stores. And we can see why we don't pick this one, because the accessibility score is a lot smaller than the other accessibility score that we were just looking at. And when I click this route, we can see when our route starts and when it ends, the total time to visit all the open houses and total miles to drive to all the open houses. We also have a route layer item. This is an item that can be used in the navigator, so we can take our pre-planned route and use it in the navigator, follow this route that we have pre-planned. Now let's jump into the code and see how it is written to execute our logic. Since we have limited time here, I will just highlight some of the key parts. So don't worry if you cannot follow all the code, since this code is included in the downloadable URL that I shared at the beginning. Also, if you are not familiar with ArcPy Next API, which is used in our script tool to do network analysis, I have a separate presentation called Python Performing Transportation Network Analysis that goes into the details for this API. So it first gets all the parameters from our tool input. Then it does some of the setup here. One of the important things I want to highlight here is this scratch folder. So this is an important trick to keep in mind because when your tool executes on server, if you want to write some intermediate data somewhere, you don't want to specify an actual path. Otherwise, every time your tool executes, it's gonna write the data in that location and it might run into conflicts over time. So scratch folder takes care of these issues. When you specify your data to be output in the scratch folder, and when it executes on the server, it's gonna create a folder called scratch within your jobs folder. So it will be unique location for each request you make to the service. So when you want to write a script tool that will eventually run as a service, always remember to use scratch folder to store the intermediate output. Here we use ArcPy Next module to solve network analysis. First, we initialize our OD solver object from the network dataset layer. Then we set our analysis settings. For the travel mode for the OD settings, we set the accessibility travel mode we get from our parameters. Here, the cutoff is used to tell the OD to stop search after we reach this distance. Then we load our open houses and the POI layer into OD as origins and destinations. Then we solve, and then we get our result back. And we can do a filter to find out all the groceries that are within a specific distance for each of the open house. Then we do an accessibility analysis based on the number of grocery stores near a house and the distance between each grocery store and the house. So this is the logic to calculate the accessibility score. And while we are calculating the accessibility score, we are also setting up accessibility index field to store our accessibility score. Then we find the open houses with the best accessibility to be the ones we will visit for the day. And for the ones we wouldn't be visit, we will write it out and using a gray color to show we wouldn't visit those open houses. Next, we initialize a route object. This route object is to solve a route to visit all the open houses with the time window. Here we specify the time units to be minutes and distance units to be miles because that's the unit we want our inputs and outputs to be. For the travel mode, we will use the travel mode that we specify to visit all the open houses. Because we want to solve an optimal route that travels from the customer's house and then back to the customer's house. So I specify return to start, preserve first stop, and find by sequence. Also, I want to get turn-by-turn directions, so I set return directions. Then we load our data. First, we load our home address into the stops. Then we load all the open houses we selected from the accessibility analysis we have done earlier. And here, we need to do some field mapping. Because our input feature class have field called start time representing the open house start time, and our internal stops have a field called time window start representing this time. So we need to map start time to the time window start, and also for other fields. And we also specify for the default visit time for each of the open house to be 30 minutes. Then we solve this route analysis to get my route. And one additional thing we are doing here is to share this analysis result as a route layer. Then this pre-planned route can be consumed in Esri Navigator app. At last, we clean up some intermediate data. So once we run this tool successfully, we can publish history item as a web tool, which essentially publishes a geoprocessing service. We can right-click on the history item, click Share As, and click Share As Web Tool. And it is going to publish a geoprocessing service using your active portal. And here, this is the same portal that we are using for our first demo. So on this Share As Web Tool pane, we can provide a name of the tool, a summary, and then we typically want to publish by reference. Did I mention the benefit of publishing by reference? You will need to set up data store to be able to publish by reference. In the configuration page, set the message level to be warning. This ensures all the error and warning messages produced by the service are returned to the client. And on the Contents pane, we can configure our tool inputs. For home address and open houses to visit, we want to set to user-defined value because we want to provide different value each time. For network dataset, we want to set it to constant because we don't want our user to provide a network dataset. We will use our San Diego network dataset every time. For the POI layer, we also want to set it as constant so that we can reuse this POI layer for our accessibility analysis. For the travel mode to calculate accessibility, because we are doing a distance-based accessibility, so we can get rid of all the time-based travel mode, and we can get rid of the tracking distance as well. We can keep everything else as default. We can then analyze and make sure everything is fine. We don't get any analyzer errors. Then we can publish our web tool. So this analyzer warning here that we are looking at is essentially telling the network dataset has not been dissolved. This could impact the performance of routing service. So it's recommended to dissolve your network dataset before using it for routing service. So once the publish succeeded, we can click this URL to go to the web tool. So this web tool can either be running from Pro or in Map Viewer, or you can consume it through the REST endpoint as well. I'm gonna show you how to run it in Map Viewer. We can click to open the tool in the Map Viewer. So now this is our web tool that could help us to plan a days of visit for the open houses. So here, we are having a new customer comes to us and want us to help plan for the days of visit. We first pull some CMS system to get all the open houses available on the market and their open house hours. And we get it into this CSV file. And this is our CSV file. It includes the name of the open house, the address of the open house, and the time window that the open house is available. We can drag and drop this CSV into the map viewer, and it will help to geocode it for us. It will recognize the address field, and when you click Add Layer, it's going to geocode on the map. Let's set to show locations only. And then we can run our analysis. For the home address, I set to meet my client near Boulevard Park, so we can click on the Boulevard Park. For the open houses to visit, it would be the open houses on my map. The customer is interested in visiting four open houses, and he is interested in getting the nearby grocery stores that driving within 2 miles. And we can provide an output feature service code, and we can click to run this analysis. So at this point, it's actually sending requests to the services that we published on our server to do the accessibility analysis and then the route analysis to figure out the open house we want to visit today and the sequence to visit all the open houses. And once the result comes back, we can look at it in the map viewer. It should have some of the symbologies that we defined on our tool. Now we get our result back. Here are the open houses that we selected to visit for the day, and this is our route. For the open houses to visit, we could configure the label to show the sequence to visit the open houses. So this shows us the sequence we will visit for each of the open house. And on our route, we also have this route layer item. We can open it up on a new tab, and we have this ArcGIS Navigator link, which we can send to our phone, and then we can open it in ArcGIS Navigator to follow the pre-planned routes that we have to visit all the open houses. So in this demo, I showed you a complex workflow which requires several tools to solve. And since we don't have out-of-box solution for this, we can build script tool and publish as web tool so it can be used as a service. Hope this gives you some idea of how to create custom geoprocessing service to solve your workflow. Back to you, Dilesh.
Thanks, Max. With that, we'll wrap up this presentation. I'm providing links to the detailed documentation for topics we covered in this presentation. These links also contain step-by-step tutorials that you can follow to learn about Network Analyst and how to publish your own routing services. Please provide your feedback for this session by clicking on the session survey link directly below this video. It helps us to improve this presentation in future offerings. Thanks for attending this workshop.
Hello, everyone. Welcome to the session. My name is Max Zhang, and I'm a product engineer on the network analyst team, focusing on the routing services in ArcGIS Online and ArcGIS Enterprise. My co-presenter, Delight, wouldn't be able to join today, so Melinda Moran here is helping us to moderate our questions and helping to answer questions that you might have. So, Melinda.
Hello. Nice to meet you all. Max, did you want to answer that first question?
Sure, yeah. So there is a question about how many instances should be dedicated to run these routing services optimally. So this question, there isn't a straightforward answer to this question, but it all depends on your use cases. Like, for example, how many requests do you expect to come to your routing services? Do you expect a peak of 6 requests per second, or do you expect a peak of 10 requests per second? It also depends on the request pattern that you are getting. For example, some routing requests take 0.5 seconds to solve. Some other routing requests that is taking much longer because it solves much larger problems. So depending on the combination of how many requests you might expect and how much time it takes for each of the requests to process, you can calculate how many SOCs you might have, so that you don't, any of the requests that comes to the service doesn't need to be queued to be returned for the answer. And in general, we recommend routing services to be on its dedicated server. So the server is dedicated to host your routing services. You can architect your, based on your own need, of course, but do not go over the physical CPU that you have on this machine. Otherwise, the SOCs wouldn't be fully performed to process your request. So.
All right, there have been several questions related to the roads and highways extension and linear referencing. So the network analyst extension is not actually related to roads and highways or linear referencing in any specific way. They're just kind of separate parts of the product. I think it might be possible to use the street feature class that you do for roads and highways in your network data set, but I'm not really quite sure on how that relationship gets maintained. So I think that if you have further questions about that, you should go to the Ask the Experts area and ask your questions in there, so that hopefully someone with more knowledge than we have about roads and highways can help you out. Thanks.
Okay, and I also see a question about, can you connect to and use ArcGIS Online Routing Services within ArcGIS Enterprise? And the answer is yes, you will be able to do that. If you are logging as an administrator account, you will be able to go to organization page of the ArcGIS portal, and then go to settings. And then there is, on the left side, there is one tab called ArcGIS Online. In there, you will be able to turn on network services and provide our ArcGIS Online user account. And then in that case, all the routing services that comes to this portal will be direct to ArcGIS Online, and it will use the username and password you provide to configure these proxy items in your portal to get your routing services. And the credits will be deducted from the user that is used to configure this proxy.
All right, so there's a question about how to prepare network data sets in the geodatabase. I think you can probably all see that in the Slido window here, and there's a link in there to the tutorial that helps you to do that. So I think that's probably your best resource.
Okay. So there is also a question about where do you recommend manually storing the network data set on the server machine? So is it inside the ArcGIS server framework folder or some other folder? So there's no constraint on where do you store your data on the server machine, but it's not very recommended to store it within the ArcGIS framework folder, because it's making the folder structure a little bit messy. But what I would recommend is if you have the SSD drives on your machine, try to put the streets data on the SSD drive so it performs faster.
Okay, there's a question about how to export your network to MMPK or mobile map package for use in the Navigator app or for use in ArcGIS Pro. There's a link in that question to the documentation for the Create Mobile Map Package tool, so you can just use that. There's also a question about the link for the demo tools and script that we showed in the presentation. I'm going to put that in the announcement area, so, or I'm going to try. So anyway, check back in a few minutes.
So there is also a question coming in for whether the geoprocessing tool that I showed will be usable in the web app builder, and the answer is yes. You will be able to use the geoprocessing widget within web app builder to consume your own routing service, your own geoprocessing services. Okay, so there is a question coming in. Do you need a license for network analysis for server to publish the routing tools? Yes, you need a network analysis extension on the ArcGIS server to be able to publish and use the routing services from server.
Okay, I just put the link to the downloads for this presentation in the announcement section, so I hope you can all see that.
So we have a question coming in. We can publish only one network data set with the utility, right? If we need to create routes across countries, we need to merge and build a network data set and then publish again. The answer is you will be able to publish routing services for multiple network data sets, but there are some special configurations. So if you want to learn more about it, you can come to our experts section and come to ArcGIS Pro. We will have stuff there that can help to answer this question about how to publish routing services with multiple network data sets. So I think there is one last question we have here is on the last demo, after you create the routing for your customer and provide a link for Navigator, does it automatically provide that link and with Navigator capability being consumed with field maps? Will field maps be an option to export a shared link? I think for this question, once you have a link for Navigator, you can send this link for the Navigator to the user who will be using Navigator to navigate. And then when they click this link, they will be able to open this pre-planned route. And then they will use the pre-planned route. They will say that this pre-planned route in their Navigator app. But I not fully following up for the last part of the question. So if you want to follow up on this question, please come to our experts in ArcGIS Pro area.
There's a question about, is a network data set more performant as a geodatabase or in the SDE database? My personal experience is that that's usually true, that a local geodatabase on disk is going to be a lot faster than an SDE instance, but I think it really depends on how fast your instance is. There are some performance improvements that come with converting your file geodatabase network to a mobile map package geodatabase. The mobile map packages are not editable, so there's a little bit of a loss of flexibility, and there's some functionality that's not available. But there have been some optimizations in terms of solve speed, and there are more coming with the next release of ArcGIS Pro. And we anticipate more with each release of Pro. So if you're super worried about speed and you're trying to solve problems with ArcGIS Pro, you might look into converting it to a mobile map package.
So there is a question coming in. Did I understand that you will need to add the street data geodatabase on all of your federated servers? We have one dedicated to batch processes. We have to place that on all the other federated servers. So the answer to this question is you need the street data. We recommend you put the street data geodatabase on all the servers that will host the routing services, because the data is on the server so that it's faster to access the data to process your request.
So unfortunately, I think we're out of time for this presentation's time slot, but if you want to follow up with us or ask any further questions, you can find us in the Ask the Experts area in the ArcGIS Pro section, and we'll try to help you out. So thanks very much.
Thank you.